28. Consider a 2-year project that, when fully funded at time zero, has a net present value of $350. The decision tree below shows the cash flow of the project when partially funded at the beginning of the year one, with an option to provide different amounts of funding at year two. This tree reflects two economic states, GE equals economic, good economy, and BE equals bad economy in each of the 2 years. For a given year, each economic state has a 50% probability. Assume the discount rate is 0%. Calculate the value of the option at t equals 0. All right, to calculate the value of the option is the value of the project with the option minus value of the project without the option. Okay, we know the value of the project without the option, which is $350 when the project is fully funded. So we know this is $350, and we want to calculate the value of the projects with the option. All right, to calculate the value of the projects with the options, we need to work out through these decision trees. And when we calculate the decision trees, we start from the end. Okay. And to work with this decision tree problems, this black square means the time where we have to make decisions. And circle means just a probability. So we don't really get to choose. Okay, so on year one, okay, by interpreting this decision tree, okay, let's start from the very top notes. On year two, it could be good economy and bad economy, and as you can see, there's no black square, so we don't get to choose if you're going to good economy or bad economy. It makes sense that we don't get to decide if you're going to be a good economy or bad economy. So we just want to calculate, when we don't see any like black squares here, we just want to calculate the expected value of payoffs. So on year two, when we get additional funds, let's suppose we get an additional fund of 700, and expected payoff would be, it is mentioned that we have 50% chance of being a good economy or bad economy for each. So expected payoff would be 50% times 1600 plus 50% chance times 1000, which is 800 plus 500, which is 1300. And since we get an additional fund of 700, the expected profit would be 1300 minus 700, which is 600. All right, so okay, let's suppose we get a 500 of additional funds, and expected payoff is exactly the same structure, so I'll just copy and paste the expected payoff, but the numbers will be slightly different. We get the same chance of being a good economy and bad economy here as well. So 50% chance of being a good economy and 50% chance for it being a bad economy. And when it's a good economy, the payoff would be 700. And when the economy is bad, the expected payoff would be 200. And when we calculate this, it would be 350 plus 100, which is 450. And we need, as we funded with $500, we have to subtract 500 from 450. So expected profit would be negative 50 because we want to subtract 500 from 450. And for, yeah, so as I mentioned earlier, if we see this black square, we have to make decision. Make decision. So we calculated, we have the value of expected profit of 600 when we fund with 700, and expected profit of negative 50 if we fund with 500. So, yeah. So of course we want to choose a, expected profit of 600. So, yeah, we would choose to fund 700 when we are in good economy. Okay, let's suppose that we are in a bad economy and calculate the expected profit for the, yeah, down the nose and the below. All right, this is same structure as well. We have 50% chance of being a good economy or bad economy. So we want to calculate the expected payoff. So I'll just copy and paste this structure one more time. Yeah. Okay. We want to, yeah, the numbers will be slightly different, but the structure is same. Yeah. Okay. So we have 50% chance of being a good economy, and the payoff would be 800, as you can see. And when it's bad economy, 600. So it'll be 400 plus 300, which is 700. And we as we funded with 300, we have to subtract 300 from the payoff to calculate the profits. So expected profits, it would be 400 when we fund with 300. Okay, let's calculate the down node. When it's good economy, the payoff will be 400 and 0 when it's bad economy. So this will be just 200. And we have funded with nothing, so expected profit will be just 200 itself. Okay, we are in this, yeah, we see this black square again, and we have to decide which is a better decision. Of course, 400 is larger value, so we want to fund with 300. Okay, and yeah, going from, yeah, so we have, so going once again, 50% chance of being a good economy and bad economy in the year one. So the expected payoff will be, yeah, same structure as well. Expected payoff of good economy in year one. Yeah, we're just calculating the year one. This would be 50% chance of, and we want to add this value to 1300 because, yeah, and we don't, since we don't have any discount rate, we can just add it. So if we are in we will be in a good economy in year one. The payoff will be 1300 plus 600. And if you're in bad economy, going down node, the payoff would be 500 plus 400. Calculating this, we get 1900 divided by 2, which is 950, plus 450, which is 1400. And we funded partially with $1,000. So we need to calculate the expected profit. We have to subtract 1,000. So the so it'd be 400. And this is equal net present value of the project when with the option. So we have came up with we have come up with the value of the project with the option, which was 400. So calculating this, 400 minus 350 equals 50. So the value of the option is $50. So the answer is B.